This is chapter 19, example 2. What we have here is a circuit that is either going to generate even parity on the output or odd parity. So it's going to add a bit to this 8-bit input. Final output is going to be either even or odd parity based on a button press. So there's a button in this. So let's do this. It's kind of an interesting top level. A par, A for A parity. Now the issue is we adding a single bit here to make it either even or odd parity. This output is necessarily going to be 1 bit greater than input, which is 9 bits. So there's a couple different ways to do this problem. Obviously, it's making a choice between outputting even and odd parity. It's going to need a mux on the output. And so what's going to decide that, of course, is that button input. And so you can called out directly in this problem. What we're going to do here is read the problem. If button pressed, it makes it even parity. So we'll say even parity generator, and we'll have an odd parity generator. And this is reading off the input. Okay, so this output here is a single bit, but it is going to be added to A, and so we'll modify this. We'll put our little plus symbol down there. So this is 8 bits. This comes out as 9 bits. Now let's do that a little bit better. It comes out as 9 bits because I'm adding this 1 bit plus these 8 bits, and this is my A par here. I am essentially going to call this done because we were able to either use even parity or odd parity box, so I didn't have to define those. So this was kind of a clunky solution. There's actually an easier solution, and I'll draw that real fast. And let's go ahead and finish the problem. So here, this is a mux here. It has a control input that's being controlled by an external input, which is the button. So this circuit has external control. What we have here is we really don't need both these circuits. If it's essentially, it's either adding a 1 or a 0 to that 8 bits, and so what I can do here is just substitute one of these circuits with a inverter, and the inverter is going to output the other circuit. So I'm going to draw that real fast. Okay, so here's my equivalent circuit here. It saved putting that other odd parity generator circuit in there. It's just taking advantage of the fact that all I need to do is invert that output of this even parity generator circuit, and that's going to give me the parity bit that I want to make this output either even or odd parity. Still has external control, and we will call this done.